All right, today we're going to be talking about the fire behavior triangle, so fuel, topography, and weather. And then we're going to be diving into the weather part of that triangle and really talking about temperature. Not so much how temperature affects wildfire in this video, just about how the different factors that decide the temperatures that you feel each day. And those three factors are going to be location, elevation, and radiation. But before we get into that, first let's just talk about the fire behavior triangle. So these are the three main factors that are going to impact, you guessed it, your fire behavior. So you have fuel, weather, and topography. Now your first thought might be, all right, which one of these is the most important? I typically tend to say fuel is the most important, except that actually isn't, I'd say, the most intelligent way to think, because in reality, all these factors interconnect so much and have such a complex interplay that it's hard to really just isolate one factor in itself. And that's really just a combination of all of these that lead to your fire behavior. So just some examples of that. How topography could impact your weather, which could impact your fuels. So let's say you have a mountain. On the windward side of that mountain, you're going to have rising motion, the rain shadow effect, where rising motion, your air cools down, squeezes out some rainfall. So then you have more precipitation on the windward side of a mountain. And then as it's descending on the other side, a lot of the moisture is already squeezed out. So you have very dry and warm conditions as that air is expanding. Another one, so that impacts your weather first, and then the weather that you have then impacts your fuels. A lot more trees on the windward side of the mountain, whereas you might have a full-on desert on the eastern side of the mountain. And then also another one for temperature to weather would be if you have canyons or drainages, that's going to impact your winds and even your temperatures to some degree as well. How you could think about that is if you have a canyon, that's going to help funnel your winds. And we see this is a pretty important part of fire behavior, especially in Southern California, where you can have the Santa Anas funneling in between different canyons. Best way to think about that is if you put your thumb over the end of a hose, it's going to shoot the water out a lot faster. That's like if you funnel your winds in a canyon. So that's an impact right there. What about fuels on weather? That one's a little more difficult, but you could say if you have a lot of trees, that would create some shading, so then things would be cooler. So then you typically have maybe more moist conditions, and that wouldn't lead to as active fire behavior. Also, if you have a bunch of trees, that could block some of the wind, and then that wouldn't spread the fire as fast. Easier one would be how weather impacts fuel. So if it's hotter out, it's typically going to be drier out. And then if it's drier out, your fuels are going to be drier, and then it's going to be easier for fire ignitions to happen, and then it's going to be easier for that fire to spread. Also, wind can actually dry out your fuels more. And then the other one that just popped up into my mind that combines all of them together, if it wasn't as complicated enough, if you have a south-facing slope in the northern hemisphere, it's going to get a lot more direct sunlight, so it's going to be typically hotter and drier. You might have more, I don't know, like a chaparral environment there. And then on the northern slope in the northern hemisphere, that's going to be more indirect sunlight. So that's going to lead to kind of cooler, more moist conditions. That's your weather impact. And then because it's cooler and more moist, you have a lot more moisture in the ground. That's going to maybe allow you to have some big trees. Whereas, so you have trees on the north side, maybe some chaparral on the south side, because of the interplay between fuel, weather, and topography. So you can't really say which one is the most important. What is interesting to say, though, is what you could say about with change when it comes to fuel, weather, and topography. And I could think of this two ways. How things change naturally, and then how humans could change things. So naturally, I think of the different time scales. So topography, that's pretty stable. That's going to be changing over, hundreds, if not thousands or millions of years as canyons are formed or mountains are lifted up. For fuels, that's going to change more throughout the season and then maybe year to year And then weather, that can change by the hour. In the morning, it's cool and moist, and then in the afternoon, it's hot, dry, and windy. So that's varying time scales when it comes to the different three factors of your fire behavior triangle in how nature changes things. But then you could also think about, well, how quickly could humans change these things? Because if fuel, weather, and topography determine your fire behavior, and like in the example of a lot of the fires in California over the last decade, we've had what you could say is too extreme of fire behavior. So we say, okay, how do we make it less extreme? Well, you have to attack one of the sides or all of the sides of the fire behavior triangle. But then you have to think practically. So with topography, how would we change that? We'd need, hundreds of bulldozers and all kinds of machinery to eliminate a mountain or fill in a canyon. That doesn't seem exactly reasonable. Now, humans can change the weather side, interestingly enough. There's things like cloud seeding. I won't get into the details of that right now, but basically you can influence how much precipitation you have in an area, which could influence maybe drought conditions, fuel conditions, wildfire conditions. If you have a city where there's lots of asphalt, that can create an urban heat island effect, so it makes things hotter. If you have a lot of large buildings, that can decrease your winds, so that would, in that way, decrease your fire behavior. Or if you have more CO2 emissions on a climate scale, that would make things warmer. And then if you had less, then it would be cooler. But a lot of the things that I just mentioned, changing those, it's very expensive. We maybe wouldn't see the results that we need right now to kind of combat this problem that we have right now in California. Maybe be over much longer time scales. And I think the best way to say it is it just wouldn't be as effective and efficient as we'd need it to be. It would be possible to change things that way, but it's not as effective and efficient as if we go to the fuel side of the fire behavior triangle and change things there. So with fuels, that's pretty straightforward. I do that personally myself every single fire season with my dad and all my cousins. We're like a little fire or fuel clearing army for my dad. We go up on the hillsides. He's chopping down some trees, taking out some brush, taking out some grasses. We're loading it in the back of the truck and creating just a huge fuel break to protect the property. So that's pretty simple. It takes us maybe 1 to 2 days at the beginning of the summer. Maybe we do it again towards the middle of the summer, blow out some of the leaves that might have fallen in. But it's pretty effective. And then if you want to do it in maybe a more ecologically friendly way, you can also kind of mimic the natural ecosystem where you can put fire on the ground, maybe trained professionals only in this regard, and then allow fire to just do the work for you. That just clears out the landscape exactly how a fire would have in the past in California, and then that also reduces your fuels. And if you have a reduction in fuels, you're going to have a massive reduction in fire behavior, because in order for a fire to continue, it needs fuel. Fire can often seem like something very extreme and out of our control. But the fact of the matter is if there's not fuel, the fire is not going to continue to burn. So if we can eliminate some of the fuel, then fire behavior will decrease. So that kind of summarizes the aspects of the fire behavior triangle that I wanted to talk about today. But now let's go into weather. So now I'm really talking about chapter 3 of fire in California's ecosystems. And it first goes into just talking about temperature in general and what's going to determine the temperature that you feel each day. And the little framework that I created so that I could remember for this video is location, elevation, and radiation. So let's look at location first. We'll go large scale first. So you could think about on the equator, you're going to have a large amount of direct sunlight throughout the year, longer days throughout the year. And then on the poles, it's going to be very indirect sunlight. So typically it's going to be warmer at the equator, cooler at the poles. Now, obviously, there's exceptions, but a lot of those exceptions are answered as we continue to talk about elevation and radiation. Continuing in location, though, we can go a smaller scale. One of the biggest things with regards to location that can change your daily temperatures is your proximity to the coast. So, water cools down and heats up a lot slower than land does. It has to do with something called specific heat. That sounds a bit sciencey, so I'll just use my favorite metaphor. If you put a cup of water out on a hot day and you put a piece of metal out on a hot day, so the metal is kind of representing your land, and you put your finger in the water after 2 hours in the sun, it'll be a little warm. It maybe went up by 2 degrees, but if you put your finger on the piece of metal, you'll burn your finger because they have different specific heat capacity. So again, sciencey word, but what that means is how quickly it heats up or how quickly it cools down. So water heats up and cools down much more moderately than land surfaces does. So what that does is the air above the water is going to heat up and cool down a lot less quickly. So then what that's going to do is moderate your coastal temperatures. So I'll just use a specific example here. You think about Sacramento in the summer. If you've ever been there in the summer, it gets very hot. But then if you drive to the west, closer to the coast, and go to San Francisco, it's a lot cooler. I think it's Mark Twain who said that coolest winter he ever felt was a summer in San Francisco. Something along those lines. And that's because we have all the cool air over the Pacific Ocean in San Francisco Bay, and then onshore winds push that cool air in over San Francisco, and it acts like some natural air conditioning. So that's where location, once again, plays an important role on your temperatures. Closer to the coast, typically cooler in summer, which is the peak of wildfire season, so obviously that's going to have some major impacts on fire behavior. So that wraps up location. Now let's talk about elevation. So with elevation, again, I'll throw out some sciencey words right here. It has to do with the adiabatic process, which is a fancy way of saying what happens to air temperature as an air parcel rises or descends. So as an air parcel, again, you can think of that as just like a bubble of air. As it rises, it's going to expand and it's going to cool down. And as it descends, it's going to contract, become more dense, and it's going to heat up. Now, the reason for that is because air pressure decreases as you go up. And if I'm getting too into the weeds, I have a nice little metaphor that I'll use in just a second. But your air pressure decreases as you go up because really all you need to know about air pressure is how many air particles you have above you. So if you're way down at a low elevation, you have all of this column of air above you, and that's weighing down against you. That's the pressure you're feeling. And that's going to lead to warmer temperatures there than maybe halfway up that column of air where you have a lot less air particles above you, so there's less pushing down on you. And the air is less dense as you go higher up, more dense typically, or of higher pressure as you are in lower elevations. And talking mostly about the troposphere here because that's where weather happens. All right, so if that didn't make sense, here's my little metaphor. So think about air at high elevations. Your air particles are going to be very spaced out because it doesn't have a lot of weight compressing it all. You could think of that like if you threw a party in a gymnasium and 10 people showed up. There's not going to be a lot of body heat going on because everyone's going to be spaced out. It's probably going to be a little awkward, but it's going to be somewhat of a cold party. You could put it that way. Versus if you throw like a frat party in a small apartment and 500 people show up, they're all going to be very densely packed together. There's going to be a lot of body heat and the party is going to be very hot. You're probably going to want to go out on the balcony and get some air throughout the party, or maybe just leave altogether. The same thing happens with your air particles at lower elevations. They're all tightly packed together, so they're going to be bumping into each other a lot more, and it's going to be a lot warmer. So now an example, Sacramento in the summer, again, pretty low elevation. That's going to be very warm temperatures, whereas Lake Tahoe still might be warm in the summer, but it's not going to be as hot as Sacramento typically, because it's that gymnasium party versus Sacramento, which is the frat party. So that pretty much wraps up elevation. Now let's look at radiation, and there's a few different ways we can go about explaining radiation, so I'll break it down into another framework. We'll go from very large scale to medium scale to small scale. So large scale in terms of radiation is going to have to do with the Earth and the tilt of the Earth's axis at 23.5 degrees. So during the summer, the northern hemisphere is tilted towards the sun, and that's going to lead to more direct sunlight and longer days, which means more radiation, which means warmer temperatures. During the winter, the northern hemisphere is tilted away from the sun, so that's going to be more indirect sunlight, shorter days, less radiation, cooler temperatures. If that doesn't make sense, the best way I think about like that direct versus indirect sunlight and how important that is for radiation is you could think about if you have a flashlight and you shine it directly at a wall, that light that it produces is going to be very intense. Versus if you tilt that flashlight up, it's going to be a lot more diffuse and it's going to be a lot less intense. So summer radiation is like pointing that flashlight directly at the wall. Winter sunlight coming in is like that flashlight kind of tilted at an angle. So because of that, again, northern hemisphere, warmest during the summer, coolest during winter. Next, we could go to the medium scale. And from that, let's just think about like a region with either cloudy conditions or clear conditions. And it's going to have different effects whether you're talking about daytime or nighttime. And then this is going to have huge impacts on the temperatures that you feel. So during daytime, probably don't need to tell you this, but if it's sunny out, it's going to be warmer. If it's cloudy out, it's going to be cooler. Because if it's sunny out, more of that sunlight, more of that radiation can make it to the surface. It heats up the surface heats up the air, and you have warmer air temperatures. So clear skies during day means warmer, but interestingly, clear skies at night means cooler. The reason for that is we no longer have radiation coming in. At nighttime, we only have radiation going out. So on a clear night, all that radiation is just going to escape straight into the atmosphere. On a cloudy night, some of that radiation is going to get absorbed by the clouds and then re-emitted back down to the surface. So it's almost like the clouds are an insulating blanket at nighttime, where it traps in a little of that heat, keeps us a bit warmer. So that wraps up the diurnal cycle that we have on maybe a medium scale. Now let's go down to the very small scale. So this is going to be something like if you have a tree, that's going to create some shade. So not as much radiation is going to make it to that shaded area, so that's going to be cooler. Or you could also talk about how well you absorb or emit radiation. For example, everybody knows that asphalt is going to be a lot hotter than grass. And then finally, I already mentioned this one, but it also depends on the direction a slope is facing. So on a smaller scale, if your slope is facing south, that's going to be more direct sunlight, more direct radiation. It's like that flashlight directly at you example. That's going to be warmer and drier, whereas that north-facing slope is going to be cooler and have a lot more moisture. So all of these different factors, elevation, location, radiation, impact the temperatures that you feel each day. And then temperature is going to be one of the key components that impacts your fire behavior. Because typically the warmer it is, the drier it is, and then the drier it is, the drier your fuels are going to be, and the drier your fuels are going to be, the more intense and extreme your fire behavior is going to be. So that's, I'd imagine, what the rest of Chapter 3 in Fire in California's Ecosystems is going to get into. And as I learn more, I'll try my best to communicate it back to you. So if you want to learn more about wildfire, you can come along on this journey with me. And thanks for watching.